Hello, everybody. This is Gabriel Cardona. Welcome to another episode of the Subnet Show. I am your host, the man with the least cats in crypto, Gabriel Cardona, coming at you strong on January the 3rd, 2022. Welcome to the future, people. I'm joined as always by my friend, the amazing man with the least cats in crypto, the yin to my yang, Connor Daly.
The most cats.
Did I say least? Oh, I'm sorry.
Oh,
Shoot.
unless something changed in the future. I don't know what happened there.
It's true.
The future's awfully nice. It's quieter. So we are pre-recording this episode.
It's actually still 2021.
Closing out 2021 for us, but trying to kick 2022 off with a bang.
Mm-hmm. So yeah, we wanted to do what we've been talking about, or the title of the show, the Subnet Show. We get comments probably every single week, literally, of people saying, "You don't talk much about subnets. What's up with that?" And there's a couple reasons for that. I think primarily that has to do with people are still in R&D phases of subnets and still wrapping their minds around them. And all of the boom has been on our C chain. DeFi is the hot stuff that's happening right now. And our C chain is blowing up around DeFi, and that's perfectly fine. We want to see more of the same. But there's no question about it. Over the last month or two, since Lisbon, I myself have been pulled into an increasingly larger number of conversations around subnets. Just helping people understand subnets, showing them what documentation and code samples we have. So there's no question 2022 is going to be the year of the subnet. So we wanted to take this episode for the first episode of 2022 and just start talking about subnets, talk about what they are, why we think they're going to be impactful, anything we know about them right now. So that's kind of where we're at right now. And we had a really big announcement last night. You want to talk about that one, Connor?
So this episode is going to be your one-stop shop for subnets and learning about them and getting intro to them. So we're going to start off with talking about what subnets are, why they're important, and then what Gabriel and I see as being the future of subnets, why they're so important, why they're going to be fundamental to not only Avalanche's success, but I think the success of the blockchain industry in general. And then lastly, we're going to kind of close the show by talking about, if you're also excited about subnets, how can you go all in on them today, January 3rd, and not 6 months from now? What can you do right now? And so, as you mentioned, yesterday we had an incredibly exciting announcement. So I guess we're dating ourselves here, but the Avalanche team recently announced that we have integrated a deploy your own EVM subnet feature with our chain, where you can actually just customize a JSON file and use that JSON file to launch your brand new EVM subnet. And so that is something that's super exciting. If you know what subnets are, that's probably super thrilling to you. But if you don't know what subnets are, that might be a little bit confusing. So to start out from the very beginning, I wrote a thread a couple months ago talking about what subnets are and why they're so important. So if you're interested in that, in this episode, I highly recommend you check out this thread. We'll link it below in the show notes. But we're kind of just going to go through some of the key ideas from that thread and use that to kind of explain the concepts. So the origin of subnets comes from the difficulties in scaling blockchains. And in fact, there's two ways that we can scale blockchains. The first is called vertical scaling, and the second is called horizontal scaling. And without sacrificing decentralization, those are really kind of the two approaches. So vertical scaling is processing transactions faster. This is having one blockchain that can just do more TPS, faster finality, more transactions processing at a time. TPS is transactions per second. And kind of the current bottleneck here is actually our state transition time and our ability to actually just write down and record all of the data that's coming through smart contract calls and processing those transactions. So whenever we have to do a token balance transfer, we have to update, the sender's balance and the receiver's balance. And, doing all of those updates for complicated smart contract calls can be quite expensive. And so there's actually a lot of work being done in this area across different ecosystems. Avalanche is doing some of our own work. The Core Ethereum Geth team is doing a lot of great work here too. But I think that those areas are going to fundamentally bottleneck. I think there's some places where we can improve, but I'm not sure that we're ever going to have like 1000x returns from where we are today.
Who do you think is the canonical example in that particular chain of thought right now? Is that ETH2, or like who is the poster child of that particular way of scaling this problem?
Yeah, I think there's nobody who's really championing this as being like the sole way to solve blockchains. It's more of like an incremental improvement rather than somebody saying.
Are there
like,
examples though? Is it like, again, is this like sharding? Like, are there examples though that are this way of thinking that are being
sharding
engineered?
is a form of horizontal. I mean, I think
Okay.
like maybe like rollups, like that might be the closest thing, but I wouldn't even necessarily say rollups are kind of, I would say rollups. So that's like doing compression, trying to fit more data in a smaller amount of space. That would be a kind of like horizontal scaling, but also just everyone does this automatically. But I think it is going to be fundamentally limited, and you're not necessarily going to be able to keep doing it forever. Like Moore's law, it's like eventually going to run out.
And so you said the bottleneck here is the state transition function. So when you've just got a massive state like Ethereum, it just takes a long time in theory, or a lot of processing power, or what, to this transition between states?
Yeah, it's just that the data structures themselves are not really super optimized right now. So for example, there's a data structure called like the Merkle Tree that Ethereum uses extensively. It uses a lot of different versions of Merkle trees, and there's like 5 of them. And you end up having to do like 6 or 7 like writes to disk for each like transaction. And it's very like the writes themselves are not contiguous. And it's just very inefficient with how data is being stored. You can fix some of those efficiencies, use different data structures, maybe replicate, maybe you actually write more data overall, or like read more data, but you just have like fewer disk accesses that would help you write a faster client. But at the end of the day, there's going to be bottlenecks that are like, correspond with like hardware speed and things like that.
And the bottlenecks we see today, are they because of naive implementations, or are they just because there hasn't been a new type of trie or something that we need yet, because nobody's taken the time to discover it, or both?
I'm not the most qualified to answer that question.
Sure,
but
it's okay. Yeah, I understand. Yeah. So I was wondering.
I certainly wouldn't say it's naive implementations.
Yeah, when I say that, I definitely don't mean that as an insult. I think you know what I mean. It's like a first draft, right? Somebody just did something, and now we have
I think that is fair to say. Is just there's solutions that were looked good at the time that when you then throw a billion millions of users at it and years of cruft and tech debt, just have problems that if you were starting from scratch, you might not necessarily run into if you had all that knowledge.
Yeah, exactly. Okay, fair enough. And then, like you're saying, there's been people who've been trying to do things such as, rewrite the EVM or different things like that. And so that's one potential way forward. But you're saying you don't think there's any more than 1000x improvement there.
I mean, the number is kind of arbitrary, but there are going to be, cannot achieve infinite.
Yeah, there's a ceiling.
You cannot achieve infinite scalability. And even 1000x where we are today probably isn't enough.
Sure.
Because kind of what blockchains are trying to do, and if you want to become a world computer, that means you need to take all of the computation globally that people are doing on their phones, on their desktops, on their IoT devices, on their TVs, and moving all of that from being on different systems into kind of a singular distributed system. Like that is far more than 1,000 times current capacity. That's maybe like, 1 billion times current capacity, something like that. So we need much more than 1000x. It's not a way to scale infinitely. It'll give you some, we can improve there, but we're going to hit diminishing returns at some point. So, how can we lock the key to infinite scalability is the question.
Okay. And so that's more horizontally?
Exactly. So there's, like I said, there's 2 types of scaling: vertical scaling and horizontal scaling. So horizontal scaling is basically replicating the number of blockchains you have and trying to process them in parallel. So if you have one blockchain that can do, let's say it does 10 transactions a second, you could vertically scale it so that it does 100, if a 10x improvement, it could do 100 transactions per second. Or you could scale it horizontally and basically replicate it potentially an infinite amount of times. And so you could also create 10 copies of that blockchain and run them all at 10 transactions per second each. And then you still have 100 transactions per second of a total throughput for your system, but it's just spread across multiple chains.
Got it. And as long as you had different types of dApps that have different separation of concerns, that would work perfectly, because you're still solving the problem of each individual dApp by just giving it its own network and its own virtual machine and its own set of validators to do its own thing. And it doesn't have to worry about anything to do with the other stuff.
Yeah, so that's the rub. When it comes to parallelization, the hard part is when the different parallel tracks have to talk to each other or communicate. And so sharding is actually, ETH2 sharding, that is a horizontal scaling solution where they want to break up the Ethereum chain into a bunch of smaller chains and have them come together back to some global consensus. So that can be the limiting factor that determines how many shards you can have or how performant they can be. Because, in the worst case, they can kind of reduce to a series execution order, which gives you no benefits of parallelism. And this is exactly how processors work as well, with different cores and things like that. If you ever have taken a computer science architecture course, they talk about how the compiler will make or you'll have different threads of execution, and they will running in a single core is really easy. But if you're going to run the same process across multiple cores or multiple processes that are using the same memory, you have to make a lot of tricky trade-offs to understand and optimizations to think about when you can use certain data and when you can't, or when you have to invalidate it and potentially recompute things versus doing things optimistically.
This is why concurrency is a nightmare, right?
Yes.
Yeah, and there's languages like Golang or Rustlang that have APIs specifically to solve this hairy problem. But it's more of a problem because computers are no longer getting fast, they're getting more parallel, right? So isn't this the problem that everybody suffers from?
Yeah, absolutely. But because everybody suffers from it, I have strong optimism that there are solutions to kind of handling this, because there are just a lot of domains that have figured out how to not necessarily be perfect, but be pretty darn good. And so subnets are a form of horizontal scaling. And so what is a subnet? So a subnet kind of fundamentally is a new blockchain that runs on the Avalanche ecosystem. And the Avalanche ecosystem can support many such blockchains running in parallel. And it takes two things to define a subnet. It takes a virtual machine and a validator set. So do you want to explain, what those two things are?
Sure. So a virtual machine is like the application level logic of your blockchain. And the way to think about it is, it's like in object-oriented programming, you have a class, and that is a blueprint where you describe an object, and then you can create instances of that class that are called objects. In Avalanche, you have a virtual machine, which, as I mentioned, is the application level logic of your blockchain. Technically speaking, it is a state machine. So you have the state of your blockchain, and there's a state transition function, and there's an API through which users can interact with your blockchain. Typically transactions, like on the AVM, you have a base transaction where you can send money back and forth. You have a create asset transaction, an operation transaction, import transaction, export transaction for doing cross-chain swaps, create subnet transaction, add validator transaction, create blockchain transaction. So there's all of these different transactions which trigger state transition functions. And then we on Avalanche will abstract away all of the networking. You don't have to worry about the data structures. You don't have to worry about the consensus. You get all of this out of the box. So that's virtual machines. Virtual machines are the application level logic, and a subnet is like a dynamic set of validators. So whenever you create a subnet, you can you have a whole range of regulatory compliance and hardware requirements, all kinds of stuff like that that you can bake into the app. You can say every one of these validators needs to be in a certain legal jurisdiction and meet KYC AML requirements, etc. They have to have these hardware requirements. and you can have a spectrum of public to private. And then you can have cross subnet asset transfers. So today you can move assets back and forth between the X chain and the P chain and the C chain. In the future, you'll be able to move assets back and forth between different subnets. So last night we launched the Subnet EVM, right? So now you can launch your own instance of the EVM. And that's a huge milestone. Perhaps now we can circle back to why that's a big deal now that we've touched on what a subnet is. Today, think how many teams out there are going to launch their own layer 1 EVM. There's still a lot of people that are going to do that, if for no other reason than R&D. You can now do that on Avalanche. Yeah, cut me off at any time. I'm going to keep going forever. You can do that on Avalanche now. So we should hope to see a lot more of these layer 1s deploying their EVMs on Avalanche.
Yeah, I mean, if you look at the blockchain ecosystem, there's so many chains that are running a version of Ethereum, whether as their main shtick or as a side shtick. I would say an Avalanche is a side shtick. A lot of people confuse it for the main shtick. Subnets are our main shtick. But you can actually basically launch Binance Smart Chain with the tooling we built yesterday in under a day, which is pretty incredible.
Oh, huge. Yeah, huge. And so that's just with the EVM. You can launch the AVM, you can launch the timestamp VM.
So just to recap, so like why are subnets a big deal? So I think they're from a building perspective, if they let you build your own blockchain on Avalanche and all you have to provide is the virtual machine, so the application rules, and then the validator set, who can participate. Is it open to the world, or is it private, or is it something in between? And so this means there's a few consequences of this. So one, just so Gabriel mentioned there's a few different virtual machines. So there's the Ethereum virtual machine that everybody knows. Bitcoin script, that's another virtual machine. Solana's Solana's backend, that's a virtual machine. Cardano has a virtual machine.
Yep.
You can run any of these virtual machines on Avalanche. You can run Bitcoin on Avalanche. You can run Solana on Avalanche. It's huge. The other thing, or go ahead.
Yeah, well, just the cross asset transfers. So a lot of people know about the network effect. The network effect is Metcalfe's law, where the value of the network is proportional to the number of network nodes in the network, and for every node that joins, the value of the network increases for everybody else. And the network effect is like gravity. So it's like the more and more people use and develop on a platform, the more people will be drawn to it, which will in turn draw more people to develop for it, etc. But there's also this idea of compound network effects. And compounded network effects are like amplified, like network effects with network effects. And they usually show up in social platforms. And the value of the different sub networks in this compound network effects they call Reed's law can ultimately just drive these exponential growths in value. And so I just really think that our subnets are primed for these compound network effects, because imagine if somebody launches there's already people working on this. Imagine when they launch a Bitcoin subnet. And so now there's a Bitcoin script virtual machine running on Avalanche. Somebody took the existing Bitcoin UTXO set and airdropped it into this subnet. So now all the people who are Bitcoin holders now hold this Avax Bitcoin. It's running with Avalanche consensus, not Nakamoto consensus. So it's doing 4,500 transactions per second. It's getting near instant finality. And then you're able to swap that asset over to the EVM or, whatever. That's really, really, really powerful.
Yeah, you made two really great points. So one is that you get the best parts of Avalanche for free. You get Avalanche consensus. We figure out basically what the next block is for you. You get that for free. You just have to determine what happens when we get that block. How do we process it? What constitutes a legal transaction? What's an illegal transaction? But we take care of the next block problem. You don't have to worry about, being proof of stake or proof of history or any of these things.
And you don't have to worry about your language. I want to point that out. So right now, our Avalanche full node is written in Golang, but the way we have it set up, we already have another virtual machine. There's already a lot of virtual machines that are coming into focus. We've been talking about them a lot at work. There's another one called the Chain Rpc Vm. And what it allows you to do is we have this gRPC API, this interface. And if your language of choice can implement this interface, then you can actually run your virtual machine. Say you write it in, a different language, C# or Rust, because they both have a gRPC libraries. you implement your virtual machine, you implement this gRPC API, and then you can run your virtual machine in a separate process than the main Avalanche Go process, and it uses a gRPC client and server API architecture. So that's even more rad because you don't have to use Golang. You can use any modern language which supports gRPC, and that's really, really cool.
And then the other point that you made that I wanted to kind of just pick up and highlight is you get instant access to liquidity if you launch your subnet on Avalanche, because building bridges is a hard problem. It actually is very annoying. You have to set up relayers. You have to have all this kind of like infrastructure on both sides of the chain.
You have to have
for every chain you want to connect.
You have to have business development relationships. There's multiple teams that need to be involved. 4, 5, 6, 7, 8, 9, 10 teams. It's a big project.
It's a giant pain. But with Avalanche, one of the key features that we're building is instant asset transfers to allow you to move any asset from any subnet into your subnet. So if you launch your new subnet, people can bridge their ERC20 tokens to you without having to build any bridges. It's just built into the network so that you can get all of the access to the entire liquidity of the Avalanche ecosystem right away. You can start getting users from day one without having to build all this extra infrastructure. And I'll say, if you're trying to build your own layer one, that's who many of the people who should be building subnets are. The process for us at Ava Labs to build bridges, the AEB bridge took, at least 6 months to put together, I think. And then the Avalanche bridge that launched this summer, I think Michael was working that for a year or two. So
yeah, he's like an amazing engineer from Cornell. Like he's not that's a serious person working for years on a project.
Yeah, it is not a trivial thing to add bridging to get liquidity to your project. Some people might offer to you to do it quickly and cheaply, but I'm just going to throw out the caution right there. This is not somewhere where you want to cut corners. And there's a lot of bad implementations that are unsafe or not performant.
And as you've mentioned, bridging is like the single biggest potential fail point in the whole entire world, in our whole entire world. If there's a bad bridge that has an infinite minting bug or something like that, it could really, really be bad for everybody. So
absolutely.
having it baked into our platform is pretty solid. And then, so what kind of virtual machines and subnets do we think we're going to see, right? Like I already know some off the top of my head. So there's obviously going to be like peer-to-peer payments. There's going to be gaming. Cut me off. We can deep dive on any of these. There's privacy, presumably. There's going to be NFTs. There's going to be things like IoT. There's going to be things like supply chain, because provenance and all of that kind of stuff does so well with the blockchain.
So you're saying, you're making some really interesting points. You're jumping to all these application specific subnets.
There you go.
We're not talking about just
DeFi.
The building blocks or like the technical foundations of a, like, Cardano is very into their UTXO model with their kind of like formal languages. We're talking about the applications. I think this is where it gets really powerful, is because you can customize your logic for a specific use case. So for example, with NFTs, data storage is a huge problem. You want to make sure that you're storing your JPEGs or your video files in a trustless format that'll make sure that those files stick around. So you might want to incorporate a file storage system into your VM, or have some kind of like IPFS link so that all NFTs are always using decentralized storage on the platform. And that's something that having just, the raw EVM could never do that. But if you're interested in making those customizations, you could.
Yeah, and the other thing that, as he mentioned, we're jumping to application-specific blockchains. So I think there's going to be, different classes of things we're going to see. We're going to see application-specific blockchains. We're going to see platform-specific blockchains, like he mentioned, Cardano and that kind of thing. We're going to see, I think, a lot of testing. So people just using subnets to spin up different instances. Like now that we have this subnet EVM, somebody could launch a EVM testing platform on Avalanche where it's super easy to spin up a super packaged and containerized instance of an EVM on a fresh subnet and run different tests and tweak it in different ways. And then, you toss that, or it lives forever or whatever, have them speak to each other. So that's very interesting. So I think there's going to be sort of different classes of applications which arrive on subnets. And then I also think once one, I guess we've already seen it with the EVM, but I was going to say once one platform launches, I think there's going to be a rush. I think there's going to be a rush to have a lot of the existing L1s launch their own implementations on our chain. And so let me see if I can articulate this a bit, because I was working on this and I actually put it on hold because I'm just too busy. I don't have time. But I was working to try and help some people from Wyoming get funding to build a Cardano virtual machine on Avalanche and a Cardano bridge. And part of the grant process, they're asking, why is this valuable? This seems like it's going to be more valuable for Avalanche than Cardano. Why would we want a virtual machine? And the way I see the value is like this. Part of the reason, in my opinion, that Ethereum is so strong in its number 2 spot is because of the Binances of the world. It's because of the Polygons of the world. It's because of the Avalanches of the world. I think all of the different instances of the EVM have helped solidify Ethereum's place in the world, as well as growing the developer ecosystem and the liquidity through bridges and all this other stuff. And so Ethereum has actually benefited from the EVM becoming the engine of DeFi as where we sit today. And so I think something like Cardano could really benefit from having a virtual machine on a subnet on Avalanche and making it part of this virtual machine store or whatever ends up launching, so that anybody can launch their own instance of Cardano in the same way they can now do an EVM. And Cardano could potentially become this engine of this next generation of DeFi in the same way that the EVM is today. So I think there is just a lot of benefit. And as soon as one of these existing popular layer 1 networks has a virtual machine, which is popping off on Avalanche, I think it's going to be a rush to get an instance of many of them, a Bitcoin one, a Bitcoin Cash one, a Cardano one, a Solana one. There could be recursively snarked VMs like Mina and Cairo. There could be a renaissance. There's going to be subnets, and virtual machines are really going to kick off a renaissance of blockchain technology, because we take all of the parts which are hard and abstract them away and give you this beautiful API. And all you have to do is focus on bringing your special sauce to this decentralized app which you're building. It's going to be incredibly exciting.
And another piece I want to call attention to is that it's not just, doesn't need to just be innovation at the application layer. It can also be innovation at the regulation layer or something like that. So because we can have private validator sets, those validator sets don't actually need to propagate they can also have private transaction histories, so they don't show up on a public explorer. So a lot of companies in the 2017 ICO boom were really interested in doing enterprise blockchain products, but they didn't really want to run their own copy of Ethereum, and they didn't want to run it on a public network. So this kind of actually provides a really great solution for them to take the innovations that they started and actually deploy them in a way that they'll feel comfortable with. So they can still have a private chain that they really only have access to, but the management of the infrastructure is ratcheted so far down. And these chains can also do KYC or something like this. So if you wanted to do a regulatorily compliant subnet that has different banking platforms that can only exist with more state participation or something like that,
or a CBDC, this is perfect
powerful
for a central bank digital currency. Like, this is absolutely one of the greatest platforms around for a bank, an actual central bank of a nation state, to come along and say, we want to use this to build our technology on.
Yeah, absolutely. I mean, you can't do this on Bitcoin. You can't do this on Ethereum. This whole idea of subnets is very much an Avalanche innovation. It's very different from the kind of implementation being pursued by like Polkadot right now. Another big part of this is subnets are permissionless. We don't charge you or require you to lock up large amounts of funds to do this. I believe the only requirement to launching a subnet on mainnet is going to be that you also serve as a validator of the P chain. And
that's correct. But and today that's expensive, and we hear that, and that's actually one of the first parameters of governance, to be able to lower the amount for delegating and validating. So we're positive that in the future that value is going to lower. It's just been a speed bump that we've had in place since we literally went live on the mainnet, but it's been on our roadmap from day one to lower that. So there's no question in the future we want to see millions of validators. Avalanche Consensus can potentially, theoretically, have millions of validators. So can we actually get the requirements of the software low enough? Because if you think about it, if you have to be a validator on the primary subnet, then it will be hard to launch an Internet of Things subnet with only Internet of Things subnet validators if they've also got to validate the mainnet. And we used to be able to launch our software on IoT devices, but recently that's not the case. But I know it's on people's roadmaps to have that be the case in the future. And so, yeah, that's very important as well to, as he mentioned, the only fee is that you have to stake to be a validator, but that's going to, the amount that you have to stake is going to decrease over time.
Yeah. So at the initial, the reason that we haven't just unilaterally changed this is because we don't want to. We think that this is like a really important network decision, and the company wants to make sure that it's decided through governance rather than through dictatorship. And so we've been waiting for actual like governance to be implemented on the P chain so that the validators themselves can vote.
Yeah, and I wanted to mention something else with regards to Polkadot. A lot of people see us as competitors. They see us as competitors with different chains. Sometimes we're an ETH killer. I spend a lot of my time debating how we're different than Solana. Sometimes we are like Cosmos because they have zones, and sometimes we're like Polkadot. In the context of Polkadot, as far as I understand it, not being a Polkadot expert, there are only 200, I believe, Polka slots or whatever the word is.
It can only be 64 parachains, I think.
Yeah, there it is. So there's only 64. That's even less. The point being, there's like this auction process where every year or two you have to re-auction your slot. To me, that doesn't sound great at all. Number one, 64 is not a lot. Like that's 64. That's a hell of a small number. What are those 64 going to be exactly? They're going to have to be platforms of their own. They'll launch different kinds of apps on them to have any value. And then every year or two having to re-auction my spot. What if you have like the game-changingest DApp of all time? What if you're the next Facebook and somehow you fuck up and don't get the auction or something and you lose your slot? That's messy. I don't dig that at all.
And that's where, being permissionless, anybody can participate. There's no limit to the number of subnets that we can have that we know of. Engineering challenges may always crop up, so you don't want to like super overpromise there. But the goal is to make it accessible. We want people to do this, and if you can have essentially infinite subnets, we think that the end state of that might even be having one subnet per dApp. If you have an app that's big enough, you could run Pangolin on its own chain. That's how you can get infinite scalability, where if you can process 2,000 transactions per second, very few apps need to do much more than that.
Sustained, especially over time, eventually the backlog is going to empty out if you get 2,000 a second solid.
Exactly. So I mean, that makes it so that you can have kind of like a microservice architecture where your exposure is very limited. You can be super customized for your experience. And this is where I think kind of the AWS model makes a lot of sense of like, you can build an EC2, like I think of like when you build an EC2 instance on Amazon, you kind of select like, okay, I want this operating system. I want this hardware requirement. I want, this much memory, this much disk, this much CPU. And you kind of just make all those selections and click boom. And now you've got your own virtual machine. And so Avalanche can be kind of the exact same thing eventually when you think of, okay, I'm building this dApp. I want to use a Bitcoin-based base layer. And then I wanted to use these different parameters. And we're going to lock it in, press launch, boom, you've got a subnet. And your application's deployed. You go start tweeting about it. And I could imagine this process takes hours, like or even minutes when it's fully featured. And I would say already our latest release with the custom EVM already lets you launch your new EVM subnet in minutes, which is just absolutely
from a single
incredible.
JSON file. I mean, that's what we're talking about. That's how you can get to what Connor's describing, where you can have a dashboard and you can fill out a form by clicking through some items on a list, and then at the end of it, click submit, and it creates a JSON field, a JSON object, and post it out to some backend, and boom, it kicks off your entire cloud infrastructure. That's very, very, very exciting, and that's going to be, there's no question about it, that's going to be very popular, I'm sure of it. So I know there was one other part we wanted to approach on this. We wanted to also talk about, if you wanted to get into this today, how would you do this kind of thing? So there were a couple tools we have, and then resources. So what are your thoughts on that? Number one, what do you think about that question? How often do you get asked that? It seems to me like there is a mad rush right now to get into the Web3 space. It could be that we're hiring a lot, so I'm interviewing a lot of people, or at least I'm meeting a lot of people. But I get a lot of people reach out to me who aren't through Ava Labs. I'm talking about just people who ping me and say, "I want to be an intern. I want to be a Web3 dev. How do I do it?" So I think the cat's out of the bag, and there's a lot of people who've got their eye on Web3 and want to enter this ecosystem. What do you think?
Yeah, I mean, absolutely. I mean, one, if you're super interested in this, you should definitely apply for a job at Ava Labs. But if
Which is
that's not your thing,
avalabs.org/careers. Go check it out. We're hiring across the board. No question about it.
But if that's not your thing, if you want to kind of like grow your runway, I totally would encourage that as well. And I think there's a lot of places where you can get into this. And the most in demand thing right now from everyone that I've talked to a lot of companies about this. They are interested in if you do run your own subnet. One key piece of information we left out: you can choose what token you use to fund that subnet and to pay gas. So this is another just super important thing of, let's say you don't want to pay Avox. Let's say you want to launch your own token. If you're running a Pangolin subnet, let's say you want to pay your fees in PNG. You can do that. And especially with cross subnet transfers, you can export PNG from the C chain and allow holders to import it on the Pangolin chain and pay all their trading fees in PNG.
And you can change your virtual machine. You don't have to burn the fees. You could give the fees to the miners, right? You can do whatever you want in your virtual machine for your validators. So you can incentivize validators by saying, "Man, not only will you can pay and ping and whatever, but we give you the ping for the fees instead of burning them like they do on the main subnet." That's a whole other thing that I think different type of fee structures are going to be very, very rich experimental ground in different subnets.
And you can capitalize this from day one. So you might see on Twitter some people toss out the term ISO, or initial subnet offering. If you want to raise funds for your project, you can do that. You can do a Genesis block with a token allocation that you give away to all your users. You can do an airdrop. There's tons of ways to capitalize on this and monetize your work on subnets. But go ahead.
Yeah, I was just going to say, we already have in the new local network runner, there's an API for creating your own custom Genesis. And I was just talking with Patrick about it yesterday. One of the things you could do with the custom EVM is whenever you spin up a subnet, you can do airdrops and stuff like that in the custom Genesis there as well. So that's pretty exciting.
Yeah. So back to your earlier question, how do you get involved today? What does that look like? So I think the first thing is just kind of exactly what I mentioned. I have this vision for this dashboard for building subnets, and I think with our first tooling with our JSON configs, it's time for that. I think if there's a really ambitious young subnetor, as the memes call them, try to see if you can build a React front end that allows you to launch a subnet from your browser. Like, if you could do that demo, it would be amazing. You would get so much love on Twitter from the Avalanche team and from the whole community.
Check out the Ethereum boilerplate that we're passing around, the Morales one for our hackathon. It's ridiculous, all the different high-level components there. That's where what you're describing should go there. There should be a React component or two that you just drop into a page and it creates exactly what you're talking about. Build a dashboard where you can build your own subnets by clicking through some different options. Today, you could already have AVM and EVM. So at the top, you could talk, or timestamp VM. We've got 3 different examples that you could already have as like a demo.
Yeah, so I mean, I think that's a really cool starting point.
There's also
a really achievable project.
Yeah, there's also a couple of libraries. We have AvaSim. So we have AvaSim, which is like a really easy way to spin up a simulator of your virtual machine. So go check out AvaSim. Go check out the 5-node network. Go check out the Subnet EVM. With regards to skills, it never hurts to learn something like Golang. I think as you on-ramp into this and you have to interface with Avalanche Go, you're going to probably want to have some Golang skills. Is that it? Or if you could only focus on one language, that would be the one, right?
I think so today, yeah. Some people love Rust, so it just kind of depends like what side of that religious war you want to fall on.
Mm-hmm.
I don't really have as much experience in Rust, but I think Golang is a really good choice. But Rust is also not a bad choice. But if you're interested in the Avalanche ecosystem in particular, I think Golang is probably a little bit better, unless you're really interested in some of the, I think Polkadot uses some Rust. So if you're interested in like bridging Avalanche and another ecosystem that uses Rust, then maybe Rust is a better fit.
Yeah. Either of them are solid languages to know for a good career path forward. There's a lot of opportunity in both languages. If you're competent, you can get a good paying job, I think, with Rust or Golang in the future for what it's worth.
Absolutely. So now once you have, if you're interested in going a little bit deeper, you're not a front-end developer, you don't want to build a web app. What are other things you can do to get involved in subnets? So I think if you're interested in experimenting, mess around with our EVM JSON config. It's actually really hard to experiment with EVM. It's not something that's super simple to like spin up a real testnet. And this is kind of basically, and you can create an Ethereum testnet as a service. And so if you want to play around with the EVM and messing around with it, this is a fantastic place to do so.
This is going to be real popular, man. It's going to be interesting to see. I wouldn't be surprised if we see Ethereum developers build tooling like what you're describing, a testnet type scenario where you can just spin up and test EVMs. That wouldn't surprise me at all.
Then, so the next thing would be, try to build a real one, not experimental. Like try to look at how you could use an Ethereum subnet to build a differentiated blockchain on top of Avalanche. Could you do something that's application specific? Pay the gas fees in your own token. Like tons of ways to innovate here. Now, if we're getting even more complicated, more ambitious, you don't necessarily have to build just an EVM-based system. You could actually start doing some of the work to port over a different chain. You could start porting over Bitcoin. You could start porting over Solana. And if you could do that and list your token as the official token and do an ISO, you could potentially capture the revenue of porting over all of Solana's DeFi apps onto your Solana Avalanche chain.
Wow, that is ambitious, man. I didn't even consider that. If you had your token be the fee value, the fee asset on a Bitcoin subnet, oh my God, you just blew my mind. You just blew my mind.
And because Solana is the only one who runs a Solana subnet right now. So all the code that's written for Solana, you could basically be the first to capture it on Avalanche.
Wow, that's amazing. That's so cool.
And that is a significant revenue opportunity if you can pull it off. Like,
heck yes.
Definitely in the millions of dollars, if not tens or hundreds of millions.
Yeah, I agree. That's very cool.
So yeah, then another option, the nuclear hardest option would be to start creating a VM from scratch.
Yep.
And this is something that, a lot of people, I agree. The EVM is the present. I think that's fairly self-evident for exactly the reasons that you talked about, or the network effects, all these people using it. It seems to work pretty well. It's been around for like 6 years. We fixed all the gaping security holes in it. We've survived. It's Lindy. But, when we look at the history of computer science, everything that we've invented has been replaced. No matter the network effects, processor architectures, operating systems, applications. There's nothing that we're still on Gen 1 on that what didn't come out in the last few years. And so I don't really see any reason why blockchain virtual machines would be the same way. And this is why I think somebody can make something that's better than the EVM. I really don't think that it is the most optimal thing that was ever created, because it would literally be impossible. There's too many lessons learned that people can have. And so eventually somebody's going to build something better. I'm not saying it's going to be us, but eventually somebody will. And this is the thing about Avalanche is Avalanche's identity is not tied to our C chain. Avalanche's identity is not tied to the EVM. We have the flexibility to become whatever the world evolves to. Whatever the future VM launches on Avalanche that is superior, we can move adoption. We can change our identity. Where if you're somebody like Solana, or if you're somebody like Ethereum, it's a bit harder to justify ditching the EVM because that's who you are, or justify ditching the Solana system because that's who you are. And moving away from that would be an existential crisis. Whereas for Avalanche, we kind of embrace that adaptability and upgradability.
Yeah, I agree 100%. That's part of our, we actually get stronger with each one because we learn and we grow into an entirely new paradigm. And as you said, we can shift and have new business relationships and new identity. It's very, very exciting. It's one of the coolest, it's the best architecture I've seen in the blockchain space. And it's just so incredibly compelling. Nice summary, man. Is there anything else? Let's see. I thought there were 3 points initially we wanted to talk about. Did we get all 3 of them?
Yeah, we did. We talked about, we introed subnets. We talked about
Woo!
what our most recent announcement meant for launching EVM chains, and then we talked about how to get involved with subnets.
Okay. All right. So now in theory, it's 2022. By the time you're seeing this, we are back at work after having a nice Christmas vacation with our family. And I believe that 2022 is going to be an insane year. 2021 was more than I expected. There's no question, as I said, looking back on the past year, it's greater than I expected. And now that I know what to expect, I think 2022 is going to be more of the same. For each one of these subnets that launches, it's going to have its own network. So think about all of the dApps that are live on the C chain. And now just imagine an entire new one that's all gaming, right? And imagine another one that's all hardcore financial services, not DeFi, but like traditional shit. And just imagine another one that's this and that. And just imagine each network is hundreds and hundreds of companies and, millions and trillions of dollars. And it's just very exciting to see the heterogeneous nature of the environment once we start getting these different subnets to take off.
Yeah, man, you put it so perfectly. I think it's a whole new front of innovation where people are not working in the blockchain space right now. There's a few people. I think Polkadot and Cosmos are the closest competitors for kind of this like horizontal scaling world. ETH2 sharding is also kind of similar, but I think the vision of having microservice dApps, each in their own subnet, is just really unbeatable. Or having the public-private distinction and like allowing enterprises to run their own subnets, or allowing enterprises to run their own public subnets with their own gas tokens so that their users don't have to pay fees. Like it's incredible. And I think that is something that, it's going to be so powerful moving forward. And it makes me super bullish about Avalanche, super stoked to be involved and like on the front lines.
Yeah, me too. Best time I've ever had in my career, for sure. Okay, so then I think we can wrap it up. Last minute thoughts. Is that it?
Yeah, no, I mean, this is about it. But yeah, thanks so much for listening. If you made it this far, you can follow us on Twitter. I am Das Connor, DAS_CONNOR.
And I am Gabriel Cardona. You can hit me at CG Cardona, CGCARDONA. And so that's it. We'll be back next week. We've got a bunch of exciting guests coming this year. Thank you for everybody who's been part of the journey. We're going to really step it up this year and hopefully have a lot more great content to bring your way. So as always, from Snowflake to Avalanche and through consensus to the stars. Thank you so much, everybody. Cheers.